Hey there, welcome back to another video of Circuit Digest. Today I'm excited to introduce an impressive application of ESP32 microcontroller. ESP32, a powerful and a versatile Wi-Fi and Bluetooth enabled microcontroller, can act as a human interface device or HID in short, and also able to emulate computer keyboard or computer mouse. That is, we can control a computer or any other device wirelessly using this ESP32 microcontroller. In this example, as you can see, I am controlling a race game using my gesture. This ADXL345 based device can be easily connected to your computer or compatible device via Bluetooth. And now let's see how to make this. But before we get there, let's have a look at DigiKey Electronics, who is not only the sponsor of this video, but also the supplier of all electronics components that you see in this video. DigiKey provides more than 13.4 million components from over 2300 quality name brand manufacturers with an industry-leading breadth and depth of product in stock and available for immediate shipment. DigiKey can act as your one-stop shop for all your electronic components needs. Also, with their fast shipping and excellent customer service, you can trust that your components will always arrive on time and in top condition. So do remember to check out DigiKey for your next project. As I mentioned earlier, ESP32 has the capacity to act as HID device. With the help of ESP32's HID functionality and the ADXL accelerometer, we can program the microcontroller to stimulate keyboard actions by gestures, like left and right clicks, front and back clicks, etc. This means you can navigate your computer interface, control presentation, or interact with applications without physically touching your computer keyboard. Here is the schematic of this project. The brain of this project is this ESP32 microcontroller. The ESP32 is a versatile Wi-Fi and Bluetooth enabled microcontroller widely used in IoT and embedded systems. Here I added complementary components for the ESP32. This USB Type-C connector is used for programming our ESP32 controller and also for charging the battery to power our circuit. The CH340 is used as a USB to serial converter. The data pins of this USB are connected to the data pins of CH340K, and the TX and RX pins of the converter are connected to RX and TX pins of ESP32. The ADXL345 is a popular 3-axis accelerometer sensor developed by Analog Devices. It is a compact sensor that measures acceleration in 3 dimensions, X, Y, and Z. The sensor can detect both static and dynamic acceleration. With the help of this, we can detect the gestures. The ADXL345 uses an I2C communication protocols, so I have connected the SDA and SCL to the I2C pins of ESP32. To make this project portable, I used a 3.7 volt lithium-ion battery as a power source. To charge this battery, I used this MAX 1898 integrated power management IC. The MAX 1898 integrates multiple functions into a single chip, including a linear battery charger, a power path switch, a voltage regulator, and a current sensor. This integration helps to reduce overall component count and save board space. Here I added a 2-pin JST connectors for connecting the battery. To filter and regulate the battery voltage, I used ADP1706 3.3 volt low dropout regulator IC manufactured by Analog Devices. It is designed to provide a stable output voltage from a variable input voltage source. Also, I have added 2 JST connectors to connect AH3377 Hall effect sensor, and which is used to stimulate 2 manual keyboard strokes. I have added a simple voltage divider for monitoring the battery status. So that's all about the circuit and working. This circuit uses a lot of small form factor components. For better implementation, I converted this circuit into a PCB using KiCad. I designed the PCB just like a mouse shape and printed the PCB. And here is the PCB. Now we can easily solder all components to its parts, and that's it. Here is the assembled PCB. You can see the JST connectors for connecting the battery and Hall effect sensor. Now we are ready to program the ESP32. So here is the code for the project. By utilizing libraries and frameworks designed for HID functionality, we can program the ESP32 act as a virtual keyboard or mouse. First, I added these libraries.
This BLE keyboard library allows you to make the ESP32 act as a Bluetooth keyboard. Then I defined the pins and other parameters like maximum and minimum voltage of the battery, etc. Also defined the address of the accelerometer. You can download the complete code from the article. So after selecting the communication port and board, I uploaded the code to ESP32. Now to enclose everything, I designed an enclosure in Fusion 360 and printed it with my Ender 3 version 2. Here's the printed enclosure. Look nice, right? After printing the enclosure, I placed the PCB into it. And everything is nice and compact now. Then I connected the battery and Hall sensors. To place this circuit in hand, I used a hand glove just like this. I have placed the magnet inside the thumb area and Hall sensors on index and small fingers. So I can control the forward and backward movement with these fingers. So that's all. Let's test it now. Now I turn on our device. Then I opened the Bluetooth menu on the laptop. Now you can see that a Bluetooth keyboard has appeared. So I connected. Now I opened this race game and we can control it by using my gestures. Enjoy it.
So that's all about ESP32 based HID keyboard. This is Rajesh. Thanks for watching. Bye bye.